owner has bought in the Santa or in any Raitu Bazaar. एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Claris. We are top on the Everest. Congratulations.
I want to be a leader.
Hello friends, good afternoon. This is Y.Usha, first MPC from G.V.Gudem, Nalgonda. See friends, mathematics is most beautiful and most powerful, colorful creation of the human spirit. Friends, see, let's look at some pictures on the screen. See friends, what is this? Yeah, this is a beautiful Taj Mahal. See friends, you are able to see the water image of this Taj Mahal in the water. Yes friends, are you able to see? Yes, we can see. And see the next picture. See friends, what is this? Yes, this is a crane and it is very beautiful white in color. Yes, no friends? Yeah, we can see the water image of this crane in the water. Are you able to see? Yeah, we all are able to see. And see the next picture. Yes friends, see how beautiful place it is. And what is this friends? Do you know what is this? Okay friends, see, this is a bridge and we can see the water image of this bridge in the water. And not only bridge, there are some trees and buildings. We can see the water image of those trees also. See the next picture. Yeah, see friends, how pleasant and beautiful place it is. And there are some trees. We can see the water image of those trees in the water. See friends, and there is another picture. What is this friends? Yes, this is a mountain. What is this? Yeah, this is a mountain and we can see the water image of this mountain in the water. Are you able to see friends? Yeah, this is a water image. See friends, another. Friends, what is this? Yeah, see, if we put a mirror here, what happens? We can see the mirror image of this heart shape half and we can see the full image like this. See friends, are you able to see here? Yes. What we have observed in all these pictures? Yeah, we have observed water images or mirror images of these pictures and we can simply say that these mirror images are known as symmetry. Today our lesson is about symmetry. What is our lesson friends? Symmetry. And in this we will discuss about the applications of lines of symmetry. What we will discuss friends? Applications of lines of symmetry. Applications of line of symmetry. See friends, do you know what is symmetry? Yeah, before going to learn about applications of lines of symmetry, let's learn about symmetry. What is symmetry friends? Yeah, I will explain you. You have probably seen symmetry in our everyday life also. See friends, every time you look in a mirror, glass and even water also, you can see a reflection of yourself. Are you able to see friends? Yes, we all see the reflections and that is called symmetry. That is called symmetry. And when symmetry is created, when there is an exact replica or reflection of a shape or a line, and this word symmetry comes from the Greek word, symmetric. Which word friends? Symmetric. And symmetric means friends, do you know symmetric means? Okay friends, symmetric means even. Symmetric means even. Even means equal in number. Even means equal in number, and here we can consider that as equal parts of a figure in this. And see friends, next see a video. See friends, how beautiful these butterflies are. Yeah, one side is as same as other side. Have you observed friends? Yes, this is that. And friends, see here, in symmetry we have 3 types. Symmetry we have 3 types, and today our lesson is symmetry, no? And we will discuss about the applications of symmetric form of a line. Applications of symmetric form of a line, and we have discussed what is symmetry. See friends, we have discussed what is symmetry, and see this video. See friends, in this the butterflies will touch their wings to each other. The butterflies touch their wings each other, and then go to the symmetrical. What are symmetrical? What is symmetrical friends? Yes, symmetrical means a figure can be divided into 2 identical parts. Can be divided into 2 identical parts, then that is said to be symmetry. See friends, see this video. Is they are coinciding? No. And see friends, they are same. One part is same as other. One part is same as other. And then friends, yes, now you know what is symmetry. Now you know what is symmetry. And then friends, we have here some of symmetrical figures are there. Here some are symmetrical figures are there. See the first one. What is this friends? Yes, this is a beautiful face of a woman. This is beautiful face of a woman, and in this one part is as same as the other part. One part is as same as the other part. And in the next picture, see what is this? Yes, this is a butterfly, and just now we have observed this butterfly. One wing is touching to another wing perfectly, and the second one is a design. How beautiful friends, it is a how beautiful design is this? And in this also, one side is as same as the other side. One side is as same as the other side. And the next picture is, yeah, this is a flower, and it is also a symmetrical figure. And this, friends, do you know what is this? Okay friends, this is a lotus temple. This is a lotus temple, and in this also left side part is as same as the right side part. Left side part is as same as the right side part. And next friends, what is this friends? We all know. Yes, this is a weighing machine. This is a weighing machine. In this also one pan is equals to another pan, or one pan is as same as the another pan. In mathematics we say that LHS is equals to RHS. LHS is equals to RHS. And friends, we have 3 types in symmetry. We have 3 types. The first one is line of symmetry. First one is line of symmetry, or axis of symmetry, or reflection symmetry. And the second one is point symmetry. What is the second one? Point symmetry. And the third one is rotation symmetry. What is the third one friends? Rotation symmetry. And in this we will discuss about the lines of symmetry. Okay friends, we will discuss about the lines of symmetry. And friends, say me, what is lines of symmetry? Okay friends, I will explain you a line which divides a figure into 2 coincidental parts, then that figure is said to be symmetrical about the line, and that line is called as line of symmetry. That line is called as line of symmetry. Okay friends, have you understood? Yeah, this is line of symmetry, and we can see friends, then lines of symmetry. And line of symmetry means a line which divides a given figure into 2 equal halves or 2 coincidental parts, then that line of symmetry is also known as reflection symmetry. That line of symmetry is also known as reflection symmetry. See friends, let's see some of the applications. Friends, do you know what are parametric equations? Okay friends, see parametric equations. Do you know friends what are parametric equations? Parametric equations of a line. Friends, given 2 points, one is x1, y1 and another one is x2, y2. One is x1, y1 and another one is x2, y2, and a point P of x comma y is on the line determined by the x1, y1 and x2, y2. P of xy is a point on the line determined by the x1, y1 and x2, y2. See friends, in this, and if and only if there is a real variable, there is a real variable t. What is the real variable? T. And such that we can write the parametric equations. We can write the parametric equations. Those are x is equals to x1 plus t times of x2 minus x1. Friends, x is equals to x1 plus t times of x2 minus x1, and second equation is y is equals to y1 plus t times of y2 minus y1. Y is equals to y1 plus t times of y2 minus y1. Friends, let us consider this is equation 1 and this is equation 2. We are using these parametric equations and we have to prove the symmetric form of a line. Symmetric form of a line. See friends, from equation 1, what we are doing friends? From equation 1, we are writing, see friends, here is x, and if we transpose this x1 to LHS side, what happens? Yes, this x1 becomes minus x1. So, we can write here x minus x1 is equals to, see friends, now here x1 is not there. So, what is remain here? Yes, t times of x2 minus x1. T times of x2 minus x1. So, here we have to write t times of x2 minus x1. Here, what we got from first equation? X minus x1 is equals to t times of x2 minus x1. X minus x1 is equals to t times of x2 minus x1. And if we transpose this x2 minus x1 to LHS side, what happens? This will become the denominator of x minus x1. This x2 minus x1 becomes the denominator of x minus x1. So, we can write this. See here, x minus x1 over x2 minus x1. X minus x1 over x2 minus x1 is equals to t. Shall I write this friends? This is correct only, no? And friends, similarly from second equation, we can write, see here, from first equation what we have written? X minus x1. So, we can write here x, y, here is y, and if we transpose this y1 to LHS side, what happens? It will become the minus y1. So, y minus y1 is equals to, this is not there now. What is remain here? Yes, here t times of y2 minus y1. T times of y2 minus y1. So, we have to write this here. T times of y2 minus y1. See friends, if we transpose this y2 minus y1 to LHS side, what happens? Similarly as equation 1, we can write this as y minus y1 over y2 minus y1 is equals to t. Y minus y1 over y2 minus y1 is equals to t. See friends, okay friends, shall I rub this? See friends, here we got two equations and those two equations are equal to t only. Yes friends, see here x minus x1 over x2 minus x1 is equals to t and y minus y1 over y2 minus y1 is equals to t. So, from these two we can write x minus x1 over x2 minus x1 is equals to y minus y1 over y2 minus y1 is equals to t. Yes friends, is it correct? Yeah, we can write this from these two equations and what we are doing? Now we are considering the only first part of this equality. We are considering only first part of this equality. See, what is the first part here? Yes, the first part is x minus x1 over x2 minus x1 equal to y minus y1 over y2 minus y1 is the first part. So, I am writing here x minus x1 over x2 minus x1 is equals to y minus y1 over y2 minus y1. This is the first part. What is this, friends? This is the first part of this equality. And what we are doing in the next step? Yeah, now we are multiplying x minus, see here friends, we are multiplying y2 minus y1 on both sides. What we are doing, friends? We are multiplying y2 minus y1 on both sides. So then what will happen? See friends, x minus x1 over x2 minus x1 into y2 minus y1. X minus x1 over x2 minus x1 into y2 minus y1 is equals to, and what is here in RHS side? Y minus y1 over y2 minus y1 into y2 minus y1. See friends, observe this RHS part. We can cancel these two, no? This y2 minus y1 and y2 minus y1 get cancelled. And what is remain in the RHS part? Yes, here y minus y1 is remain. So, I am writing this y minus y1 in LHS side. Y minus y1 is equals to, here what is remain in the LHS side? Yes, here x minus x1 over x2 minus x1 into y2 minus y1 is there. And we can write this as x minus x1 times of y2 minus y1 over x2 minus x1. Can I write this, friends? Yes. See friends, let us consider this is equation 3, and by observing this one, what are you remembering, friends? Yes, absolutely. This is the formula for slope of a straight line. This is the formula for slope of a straight line. Next, go to the next step. Friends, shall I rub this? Yeah. See friends, this y2 minus y1 over x2 minus x1 is the slope of a straight line. y2 minus y1 over x2 minus x1 is equals to, what is this? This is the formula for slope of a straight line. Slope of a straight line. Then friends, we have another formula for slope of a straight line. Do you know that, friends? Okay, another formula is slope of a straight line is equals to tan alpha is equals to tan alpha. This is the another formula for this slope of a straight line. And see friends, by looking these two, we can write y2 minus y1 over x2 minus x1 is equals to tan alpha is equals to tan alpha. Shall I write this? This is correct only, no friends? Okay, this is correct. And let us consider this is equation 4. This is equation 4. See friends, if we substitute this equation 4, in equation 3, what happens? See friends, what is equation 3 here? Yeah, this is the equation 3. See, y minus y1 is equals to x minus x1 times of, here y2 minus y1 over x2 minus x1 means what we are substituting here? Yeah, we are substituting tan alpha. So, we can write tan alpha here. See friends, from trigonometric identities, this tan alpha can be written as, what we written? Yeah, sin alpha over cos alpha. Sin alpha over cos alpha. We can write tan alpha like this. So, we are writing this. Friends, shall I rub this? Okay friends, now what we are doing? we are substituting the sin alpha over cos alpha in the place of tan alpha. See, same in the equation, y minus y1 is equals to x minus x1 times of what I have to write here now? Yeah, I have to write sin alpha over cos alpha. Sin alpha over cos alpha. See friends, we can write this as, see, y minus y1 over sin alpha is equals to x minus x1 over cos alpha. See friends, we can write this equation like this, y minus y1 over sin alpha is equals to x minus x1 over cos alpha. So, this x minus x1 over cos alpha is equals to y minus y1 over sin alpha is this, therefore, this is the symmetric form of a line. This equation is the symmetric form of a line. Straight line. See, this is the equation. Why we are using parametric equations means, these parametric equations are also one of the applications of symmetric form of a line. Friends, let's see some more applications of lines of symmetry. See friends, see on the screen. Yeah, what are those friends? Yes, we all know these are alphabets, and this is also application of symmetric form of a line. See friends, here letter A is having vertical line of symmetry. Letter A has vertical line of symmetry. If you were to fold this alphabet A along this line, what happens? Yeah, one part will coincide with another part. One part will coincide with another part, and similarly this B has horizontal line of symmetry. B has horizontal line of symmetry. Then like that only C, D, E all has horizontal line of symmetry, and H, I has two lines of symmetry. Those are horizontal line of symmetry and vertical line of symmetry. Friends, I want to say another thing, that is in lines of symmetry we have four types. In lines of symmetry we have four types. The first one is vertical line of symmetry. And the second one is horizontal line of symmetry. The third one is multiple line of symmetry. The fourth one is zero line of symmetry or no line of symmetry. Here the alphabet A has a vertical line of symmetry, B, C and D, those have horizontal line of symmetry, and H, I, these two letters have horizontal line of symmetry and vertical line of symmetry. So, they can be called as multiple line of symmetry. And then friends, there is a letter F. Do you know that letter? Yes, we all know. And that is that letter has line of symmetry? No friends, it has no line of symmetry, because if we fold that letter, it cannot be coincide with another side. So, it has no line of symmetry. See friends, see a video here. What is this friends? Yeah, see, something is forming there. What is that? Can you have any idea about that? Yeah, we have an idea. This is a smiley face and this is the image of this. See friends, here what is the line of symmetry? Yes, this red color line shows the line of symmetry of this smiley face, and we are going to learn about line of symmetry, and these are the applications. See friends, a line of symmetry is an imaginary line that can be drawn through an object where one side is a perfect reflection or a mirror image of the image. See friends, where one side is a perfect reflection, a mirror image of the other side, and you can think of line of symmetry as a line on which we can fold the image, and if both halves line up perfectly, there is a line of symmetry. Otherwise it is not. See friends, here is an example. For example, see this butterfly. See friends, how beautiful this is, and this has a vertical line of symmetry. This has a vertical line of symmetry. If you were to fold this butterfly along this line, this will be like this, and these are the reflections. Each half would match exactly, and these are the reflections. So, we can also call this as reflection symmetry. We can also call this as reflection symmetry. See friends, how many lines of symmetry are there in this butterfly? Yes, only one line of symmetry, that is this vertical line of symmetry, and these two blue lines shows the reflections of this butterfly. And friends, then let's look at some common polygons which have lines of symmetry, and see here. First we consider triangles. What are triangles friends? Do you know? Okay, triangles means a polygon which has 3 lines. A polygon which has 3 lines, and see, what is this friends? Yes, it is a regular triangle. Regular triangle means it is an equilateral triangle. See friends, for a common triangle and a regular triangle, there is a difference. See, common triangle means it can be have any sides and any angles. But in regular triangle, all the sides are equal and all the angles are equal. Understood friends? Are you following me? See here, all the sides are equal and all the angles are equal in a regular triangle, and it is also called as an equilateral triangle. Let's see the lines of symmetry for a regular triangle. See friends. See, this is this a regular triangle? See, how many lines of symmetry are there in this regular triangle? Yes, there are 3 lines. Let's see the foldings of this. See, observe carefully friends, is they are coinciding perfectly? Yes, they are coinciding perfectly. So, we can say that this equilateral triangle has 3 lines of symmetry, and here is another triangle. What is this friends? Yes, this is an isosceles triangle. Friends, say me, is this a regular triangle? Yes friends, you are right. This is not a regular triangle. Why friends? Yes, because in this isosceles triangle, only these 2 sides are equal and the third side is not equal to another side. So, it has only one line of symmetry. It has only one line of symmetry, that is this. And let's see the folding. See the folding friends. Is it is coinciding perfectly? Yes, it has coincided perfectly. So, it has only one line of symmetry. And then there is another triangle. What is that friends? Yeah, another triangle is a scalene triangle. See friends, is this a regular triangle? No, it is not a regular triangle, because in this also all the 3 sides are not equal. In this the 3 sides are different. And let's see how many lines of symmetry it has. See friends, here is a folding, and say me, is it coinciding perfectly? No, it is not coinciding. That means this scalene triangle has 0 line of symmetry or no line of symmetry. 0 line of symmetry or no line of symmetry. Friends, next go to quadrilaterals. What friends? Quadrilaterals. Friends, remember, different quadrilaterals have different number of lines of symmetry. Different quadrilaterals have different number of lines of symmetry. See friends, here is a square. What is this friends? It is a square, and if we fold this along these lines, these are coinciding perfectly. See friends, is they are coinciding perfectly? Yes, and if we fold this like this also, they are coinciding. See friends, is they are coinciding? Yes, and diagonal, if we fold this diagonally also, they are coinciding. Yeah, and another diagonal is there. See, observe carefully friends, is they are coinciding perfectly? Yes, they are coinciding perfectly. That means how many lines of symmetry this square has? Yeah, see, 1, 2, 3 and 4.